Alright, this next problem that we're going to be looking at is on maximizing revenue. This is from Chapter 3, Section 4, page 160, and it's problem number 4. We are given the price P in dollars and the quantity X sold of a certain product. Obey the demand equation. P equals negative 1/3 X plus 100. Okay, part A, we are going to find a model, that means an equation, all right, that expresses revenue R as a function of X. Well, R equals X, the quantity sold, times P, the price. Okay, if we want to write this as a function of X, we could say R of X equals X times, in place of P, we are going to write what P is equal to, negative 1/3 X plus 100. Okay, now we could leave it like this, or we could simplify by distributing the X. So R of X equals negative 1/3 X squared plus 100X. There we go. And that's part A, finding the model that expresses a revenue as a function of X. Now part B asks about the domain. Alright, what we need to do is we are going to put 0 in for R of X and solve for X. So for part B, let's use this color here. Part B, we replace R of X with 0 and we solve for X. Okay, well, first thing I'm going to do is I'm going to factor out an X, and I'm going to interchange equals, put each side of the equal sign. So I'll write negative 1/3. I'm going to take X times this. Okay, negative 1/3 X plus 100. And I'm going to set this, it's equal to 0. Well, to solve this, we take each factor and set them equal to 0. So X equals 0 and negative 1/3 X plus 100. Also equals 0. Well, the first one, X equals 0, is already solved for X. For this one, we have to subtract 100, so we have negative 1/3 X equals negative 100. Alright, multiply by the reciprocal of negative 1/3, so that means negative 3 times the entire equation, so X will equal 300. So that means our domain is between 0 and 300 is where X is defined. So I can write this, let me put this up here. If I'm using a set builder notation, I would say we have a function in X such that X is between 0 and 300. Part C. What is the revenue if 100 units are sold? So for part C, all we're going to do is we are going to plug in 100 in place of the x. So for part C, we're going to take our equation. We're going to say R of 100 equals negative 1/3 times 100 squared plus 100 times, and in place of x we put 100. Alright, when we plug 100 into our calculator and simplify, we get R of 100 is equal to 6,666 point, and we're around to 2 decimal places, so 67. So since this is money, we have $6,666.67. That's what we get when we put 100 in for x. Now, part D. What quantity maximizes the revenue? Well, if you think about this, we have a parabola. Alright? What this function really is if we just had a generic function, since the squared term is negative, it looks like this. We want to find the maximum revenue, which would be the vertex. So we are going to use the formula x equals negative b over 2a. Alright? A is negative 1/3, b is 100. So negative 100 over 2 times negative 1/3. Alright, when I simplify this, we get that x is equal to 150. That is the x-coordinate of the vertex. To find the y-coordinate, we plug 150 in for x. So we find R of 150. So we take negative 1/3 times 150 squared plus 100 times 150. Alright, when we simplify, we get R of 150 is equal to 7,500. So that means our maximum revenue would be $7,500. And last, we need to do part E. What price should the company charge to maximize revenue? Well, if we want to get the maximum revenue, that means we need to put the largest value for x, the vertex, in the original equation for p. Okay, so let's see. Alright, part E. Alright, we're going to take our equation P equals negative 1/3 x, and in place of the x, we're going to put our 150. So 150 plus 100. Alright, now when we simplify this, we get P equals 50. So the price we should charge is $50. And there we have it.